Okay, so we're going to talk about probabilities. So now I'm recording out of order, and that'll change slightly what we do because one of the things we want to do is probability using area. So the more things of which you know how to calculate the area, the better. But we will do what we can. So generally speaking, let's state some rules about probability. You've probably heard it given in percentage form. So that's one way, but remember that, I've changed my chalkboard as you can see, so I probably need a lighter color. Probably not green. Okay, so this means for each 100. So when you write this, you're dividing by 100. So whatever's on the left, you would have multiplied by 100. So things on this side of the percent sign are between 0 and 100. So 0% less than or equal to any probability. So this is a notation. If you put capital P, if you're in a finance class, it means profit. But if you're in a statistics or probability class, this capital B means probability of, and then this is just a placeholder. So this might be a set of things, this might be an exact outcome, but at any rate, probabilities have to be between 0 and 100%. You can't really give 110% unless you're talking about money, and then it's 110% of something that you have more than a whole of, but probability, you're stuck between here. So if we recognize that we've multiplied by 100 in order to write these percent signs, then it also follows that I can divide by 100 and not put the percents. So probabilities are between 0 and 1. If something is certain to happen, it has a probability of 1. If something is certain to never happen, it has a probability of 0. So 0 means will never happen, 1 means will always happen. And we have a couple of different ways that we'll look at probability right now. So one of them is the case where you kind of count things. So that's where you have the probability of someone rolling a 2 with a die, or someone flipping a coin and getting heads, or someone choosing a person out of a group. Things like that, where the probability theoretically of each given event is the same. So if I have a die, so if I have a die like this, when I roll it, the probability of getting 1, 2, 3, 4, 5, or 6, these are all equal. So they're called equally likely events. In the case of equally likely events, if I have E, which is a complete event, so each one of these might occur, but I might have the event of getting a 2 or a 3, so a set. But the probability of getting either a 2 or a 3 is the number of ways to get an E divided by the total number of outcomes. So 1, 2 over 1, 2, 3, 4, 5, 6, if you're rolling a 6-sided die. And then you simplify that to 1/3. So if I want to know what's the probability that I roll a 2, there's one way to roll a 2. It's the rolling a 2 way of rolling a 2. And there's still 6 outcomes. The probability that what I roll is, say, prime, and this is shoddy notation, but we'll live. That's the probability of a 2, a 3, or a 5. That equals 1, 2, 3 over 6. Probably so far you would have guessed these things. This is sort of an intuitive situation. But let's say that I'm going to roll 2 dice. And I want to know the probability that the sum is 5. Because often in games, you roll dice and you add up the 2 sides. This is not one out of the 11 options. So there are 11 options because you can't roll a 1. You can roll a 2, a 3, a 4, a 5, 6, 7, 8, 9, 10, 11, 12. There are 11 options. But this is not the case. And the reason is because these are not equally likely. The only way to get a 2 is by rolling 2 ones. I can roll a 3 by getting a 1 and a 2, or a 2 and a 1. I can roll a 4 by getting a 1 and a 3 and a 1, a 2 and a 2. So some of them have more ways to be rolled than others. Generally, there's this chart. And this is, the first die. It doesn't matter what order you roll them in, but you need to count 1 as first to kind of make sense out of the possibilities. Oops. I really need to learn how to get rid of that thing. Okay, so I'm just going to write a little 6 there. So if I roll a 1 and a 1, the sum is 2. You can use a chart like this too if you were doing, multiplying them, or even if this was a die and this was a coin, the 6-sided die, 12-sided die, whatever. So we have one thing on one side and the second thing on the other side. And 2 and a 1, since I'm adding them, that makes a 3. 1 and 2 makes 3, 2 and 2 makes 4. And if you keep doing this, you'll soon find out that these make diagonals. Ugh, it's a beating. Well, pretend that you can see all these. Maybe I can sneak them in. Well, okay, so the probability of a 5, there are now 6 times 6 little squares. 1, 2, 3, 4 of them are 5s. So the probability of 5 is 4 out of 36. If on this one I say, nope, that's not what I want. If I say the probability of an 8, 1, 2, 3, 4, 5 out of 36. This one I would have reduced. This one I can't. In this case, if I say probability of a prime, then one thing I can do, if I have the chart on paper, of course, is say, okay, 2's prime, 3's prime, so these so far, 5, 7. If I had a different color, I could mark these better, and 11. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And I would reduce this. Okay, so this is just, I've got equally likely events. 2 through 12 aren't equally likely, but once I list them like this so that I have 2 3s and 3 4s and so forth, now each of those little squares is equally likely. So I can just add them up. Okay, so sometimes counting is a bit more complicated. So we might have, say, a class with 13 girls and 15 boys. So then if the question was, let's say I'm going to choose I'll start with 3. I'm going to choose 3 learners to go to Six Flags. I'm not actually, so pretend that we were. Then we might say, what's the probability that they're all girls? Okay, so this is a little more complicated way of counting because now we're choosing 3. We can't really draw a chart that shows 3 ways, right? We can draw it 2 ways easily, but 3 ways is a little harder to sketch. And if I said 5, then that doesn't even happen in our reality, so we certainly can't do it. So here's what we do. We still need, this is the number of all-girl committees divided by the number of possible, well, committee is a word that's used frequently in public, groups, the number of groups. So this is all the options I have, and this is the options that are all girls. So here's the way we think about it. The first thing is, I have to pick girl, girl, girl. So this is for the number of ways of all girls. I shouldn't have drawn that. I was going to make that more complicated looking than necessarily. Okay, so first I have to pick a girl. There are 13 choices. And then I have to choose a girl again, but now one of them's already going, so I'm not going to choose her again. So now I have 12 ways to do that. For each of these 13 choices, I have 12 choices. So this gets multiplied. It's like a branching tree, so I've got 13 choices, and from each one of those branches, I have 12 branches going off. Now that I've chosen that person, I have 11 ways to choose the third. The only problem with this is that one of these choices might have been Miss Moore, Miss Platt, Miss Cone. And another one would have been Miss Platt, Miss Cone, Miss Moore. And another one, Miss Cone, Miss Platt, Miss Moore, and so forth. So I've counted the same group actually multiple times. So if I knew how many times I chose each group, I would just divide by that, because I did them all the same way. So let's consider the Miss Moore, Miss Cone, Miss Platt way. The number of ways I could have chosen first is I either could have chosen Miss Platt, Miss Moore, or Miss Cone. So I had 3 options on the first go. Once I know which one I chose first, I have 2 options left, and then 1. So this is what I need to divide by to find out the number of ways I could have chosen all girls. So your calculator has a function. So I don't have a TI-84 Smart View on this computer. So I'm just going to tell you, if you have a TI-82, 84, something along those lines, you go to Math, that's a button, and then you scroll over to PRB. That stands for probability. And then what you're looking for is NCR, which is maybe 4. I don't remember. You're looking for this. What this means, the C actually stands for combinations, but combinations means like collections. So this is, if you have N objects, how many ways can you pick a combination of R of them? Most people say the word choose. N choose R. So we're just choosing this many. So in this case, I would have had 13 choose 3 because I'm choosing 3 of them. This is also well, just put this over on the side. Okay, so this means n times n minus 1 times n minus 2 and so forth down to 1. So like 5 factorial, this says factorial, is 5 times 4 times 3 times 2 times 1. That's just what this exclamation point means. And you can see that this kind of looks like it may be related to this. So if I wrote 13 factorial, the problem is that I don't have the 10 and on down. So I need to divide by the 10 and on down. And then these two together give me just this. But then I also have actually this, right? So 10 plus 3 is 13. 3 is the number we're choosing. None of that's coincidence. So n choose R is n factorial divided by n minus R factorial, so that's the part that we weren't going to write down, being divided back out, and then R factorial, and that takes care of the I counted it too many times. Okay, so this is the formula for that. And back in the old days, we didn't even have calculators that did this, and honestly, I found factorials to be pretty fun. So you can take a screenshot right now if you want to keep track of this, because I'm about to erase part of it. N factorial, by the way, is also in the probability thing on your calculator. I keep making my chalks. Okay. So the cool thing is that combinations are always going to give you a whole number because you're counting the number of ways to do a thing. There shouldn't be half a way. So if this is mathematically valid, jump's going to cancel out. So you can always cancel everything from the bottom out from the top. So you can use your calculator to do it. Again, I just don't have one, so I'm just going to do it the old-fashioned way. I'm going to mark out the 3 and the 2 and make this 12 a 2 because they're actually both in it. So we've got 13 times 22, which is 286, I think. Okay, so that's the number of ways. Remember, so far all we've done is get the number of ways to pick the girls. So we still have the issue of how many total groups do I have? Well, in reality, I have 28 people, right? So 28, 27, 26, still with the 3 times 2 times 1 ways that I grouped them all. Because this time maybe I picked Miss Platt, Miss Moore, Mr. Young, but I could have done Mr. Young, Miss Platt, Miss Moore, and so forth. So I still counted them 6 ways. This time, 6 doesn't go into any of my numbers, but 3 from 27, 2 from either one of these. So we have 28 times 9 times 13. Which I think is 3,276. So we have 286 dividing by 3276. It might have also behooved us, if we were going to do this, If we were going to do this by hand, which you're probably not, we could have left it 13 times 2 times 11 divided by 28 times 9 times 13. And kind of pre-simplified the thing. So now we have 9 times 14. Or you can put this in your calculator or, write this down. If you put something in your calculator, you can also hit math, frac, enter, and it'll turn it into a fraction instead of a decimal. So I don't know if you knew that, but if all you want to do is simplify, then you could say like 5,428 divided by 9,676, and let's say you don't have a clue how to simplify that, you can put that in your calculator and then math, frac, enter, and it'll simplify it for you. Darn it. Do that. Okay. So if I wanted the probability of choosing all chocolate candy from a container of, how's this for shoddy notation? 5 Snickers, no, we'll say M&Ms, 4 Hershey's Kisses, and 8 boxes of Runs.
Take a famous song.
Pretend that their size doesn't matter, it does, but this is packaging M&Ms. So let's just say somebody else is choosing for me and they have no interest in what I get, and size doesn't matter on these. Then what we would say is this is the number of ways I can choose. Oh, if I'll say 4. So let's say I'm going to get 4 pieces of candy, and I want to know the probability that all four of the packages are chocolate. Then first, I've got total 17 packages of candy. 5 plus 4 plus 8, 17. And I'm going to choose 4 of them. And then down here, I've got, oh, sorry, wait. Paying attention to the wrong things right now. Okay, need to get back on track. So, the total number of ways to choose, I've got 17 and I'm going to choose 4. But as far as chocolate, I've got 9 because the M&Ms and the Hershey's are both chocolate. So I have 9 out of which I need to choose 4. Okay? So I have 9, 8, 7, 6, and if you were plugging in the whole formula, you'd write 4, 3, 2, 1, 5, 4, 3, 2, 1, and then down here you divide by 5, 4, 3, 2, 1. So I guess 5, 4, 3, 2, 1. So that's the N minus R part, and then also 4, 3, 2, 1. Down here, I'm not going to write out the whole formula down here because I don't have enough space. So I would have 13 and on down, and I would divide by 13 and on down, and then I would divide by 4, 3, 2, 1. So these cross out. So I have times, I'm dividing two fractions, so let's see. I can get rid of 6 by taking a 3 from here and a 2 from here. And then I can get rid of 7. 16, I can write a 2 and get rid of the 8. Okay, so I have 9 over 17 times 2 times 5. 9 over 170. Okay, so again, you're looking at this scared, but what you would have put in your calculator is this. Oh, the way you put it in, so the way you put 9 choose 4 in is you go 9, math, probability, it's just PRV, NCR, 4, enter. That's how you put it in. I'm sure Desmos does this in some way. I'm not sure if I know how to figure it out, but we can definitely do one thing. Yeah, there we go. Okay, so 9 NCR. Oh, it does it differently. So in Desmos, you would put NCR 9, 4. And then out here, we want divided by functions NCR 17, 4. Okay, so it doesn't give you the fraction, however. Nope. So I don't see any way for this to make this exact. So I think if we do it this way, we'll have to allow for decimals. So I guess I'll just have it allow for decimals. And if you do it with your calculator, don't do MathFrag. Okay, so what we ended up with was 9 over 170, right? See? So it's the same. All right. Let me do one other thing with this, just because there's also, let's go back to the one where we had 13 girls and 15 boys. Now the way that I calculated, I was trying to convince you that it's how many ways can I choose this times how many ways can I choose this, and so forth. So let's say that I was picking a group of 4. And let's say instead of the probability of all girls or the probability of all boys, I wanted the probability of 2 girls and 2 boys. So you do it like this. You say, okay, Say, okay, well, I need to choose 2 girls out of 13. But for each of these choices, I will have all the different combinations of 2 boys. So then out of 15 boys, I need to choose 2. And these get multiplied because, again, it's like a tree. For every set of 2 I've chosen here, that can be partnered with every set of 2 from over here. And then down here, we have 28. Choose 4. Okay? So I personally would do 13 times 12 over 2, 15 times 14 over 2, 28, 27, 26, 25, 4, 3, 2. Interesting. Okay, so unless I've done this wrong, this should come out 0.4. Okay, so that's how you would do it in Desmos, and if you were doing it in a TI calculator, I don't know that an Inspire, it probably is still the same, but I can't be sure. So you would have gone 13 math, probability, NCR 2. Okay. Now, I need to talk to you kind of briefly now about something called permutations. And the P you can think of as meaning place. So in a permutation, you care what the order is. So now, let's say instead of just taking a group of 4 to 6 flags, the first person was going to get $25, and the second person was going to get $20, and the third person was going to get $15, and the fourth person was going to get $10. At this point, the choice, Miss Moore, Miss Platt, Mr. Young, Miss Cone, is not the same as Mr. Young, Miss Cone, Miss Platt, Miss Moore, because they get different amounts of money, so they care who's chosen first. So that means we don't divide out by that 4, 3, 2, 1. Okay, so now the number of ways to choose 4 in order is we would just say, okay, 28, 27, 26, 25, and not divide by anything. So that's like 28 factorial, but I still need to get rid of this part that I didn't write in. So this is in PR, and this is n factorial over n minus r factorial. So that, again, just deletes out this last part. But we're not dividing by the number of ways we counted something because we want them all to be different. Okay, so let's say that we're doing that same group. But you want to know, you're going to choose a president, vice president, and secretary. So you want to know the probability that the president is a girl, the vice president is a boy, and the secretary is then a girl. So you have 13 ways to choose the president, you have 15 ways to choose the vice president, and then you only have 12 ways now to choose the secretary because one of the girls has already been assigned. And you divide by 28p3 because order is mattering. You could have also said, because it doesn't matter if I state it as president, vice president, secretary, or president, secretary, vice president, you could have also said, out of the 13, I'm going to place 2, placing them here and here. And out of the 15 boys, I'm going to place 1. I place him here. So it doesn't matter what order. Then if I write it this way, for one thing, it's more transferable to larger groups, but this just puts 13, 12, 15 instead. So it just rearranges the order. In multiplication, that doesn't matter. So this is what we get. Okay? Now, the number of ways to either choose or place one person is just the number of people there are, right? Because you only have one spot to chunk them up. So we can go ahead and write this out. Cancel some stuff out.
I'm just thinking you, 'cause you're in Southern California, the fertile land runs down
28.
that road. But when I came,
Oh, I should have canceled this.
could be spared for you. You see,
Okay, or we can use the calculator. So 13, well, let me get a new box. Out of 13, we placed 2 in their positions. And out of 15, we only placed 1 in his position. And for how many ways we could have done it all together, we had 28 people and we placed 3. Okay, so this is how we do that. Now, the other way we want to look at probability is as an area, because it's not always the case that you can count up the possibilities. Sometimes they're what we call continuous. So I'm just going to kind of look at it from a dartboard standpoint, and then hopefully you can extrapolate that. So if you're using area, the probability of an event is the area of the event divided by total area. So let's say that I had a dartboard. And let's say that the radius of this little guy was 1. And then from here to here was 2. And from here to here was also 2. So that means the radius of this entire thing is 5. Okay? So let's say at first I wanted to find the probability of a bullseye. Then what I need is the area of the bullseye divided by area total. Okay? The bullseye has radius 1, so that's pi times 1 squared. This has radius 5, so pi times 5 squared, so pi over 25 pi, or 1 in 25, okay? What if instead I wanted to know just the probability of this area here? Maybe that's for 10 points or whatever. So you want to know the probability of this. So first you need the area of that bit divided by the total area. We already know the total area is 25 pi, so that's going to remain the same. For this top part though, what we have to do is take the area of this entire circle and then remove the area of the bullseye, because we don't want to count that now. So we do the area of the somewhat larger circle, which is pi times 9, 3 squared, I'll write in, minus the bullseye, which we've already calculated to be pi. So this is 9 pi minus pi over 25 pi. So if I have 9 pi's and you take one away, I have 8 pi's. 8 and 25. Okay, so I'll do one more area problem, I guess. We can't do too very many because we haven't covered all the various areas. So let's say that you have a rectangular garden, and let's say this is, actually let's make it a sandbox. So this sandbox is, say, 6 feet. Is that too big for a sandbox? Say by 3 feet. And let's say that unbeknownst to you, there's a little snake coiled in here. And let's say that this little snake is in the shape of a circle. This is all pulled up and scared under the sand. And let's say that the radius, or let's say the diameter, that's probably a more reasonable thing to know about a snake. Let's say that little diameter is 6 inches.
Art and Soul, hosted by singer-songwriter Caroline Jones and special guest Doug Paisley.
Tonight, 10 p.m. Eastern, 7
Okay, so let's say you're just going to jump kind of wildly in the sandbox and you want to know the probability you land on the snake. Let's ignore the size of your feet for a minute. Okay, so what we want to know is the area of the snake divided by, or the area of the top of the snake divided by the area of the sandbox. Okay, so the first problem is we're in inches and feet. So we need to translate one way or the other. We can either call his diameter half a foot, or we can make these into inches. It doesn't really matter. We're going to have to reduce everything out in the end. I guess that I'll go ahead and make these inches just because I'm really going to need to square the radius, right? So I'm going to have, if I make the diameter half, then the radius is the fourth, and then I have to square that, and I have a 16th, and I'd just rather deal with translating these now than having fractions divided by things. So 6 feet is 72 inches, 3 feet is 36 inches. So the area of the snake is pi times the radius, which is not 6 but is 3 squared. And we have inches squared, right, really, but we're going to have that in both cases. So I have 3 inches squared. Let me write this out carefully because keeping up with units actually is a problem for people. 3 inches squared. And then down here I've got 72 inches times 36 inches because the area of a rectangle is length times width. Okay, so I have pi 9 inches squared, 72 times 36 inches squared, because inches times inches, it's like x times x, right? So if you had 72x times 32x, you'd pull out the x squared. So now these cancel, and 9 goes into 36 4 times. And this is your probability. Okay, so hopefully that all makes sense, and I will write an assessment for this one hopefully today, and then I'll see you guys tomorrow and see, or some of you, and see what questions you have.